Morning, everyone. It's a pleasure to meet you all. We're just going to start in a few minutes and wait for a few more people to join. But we'll get started promptly at 11 o'clock. Thanks for joining. All right. Good morning, everyone. My name is Tiwari, and I'm the Canada Sales Manager for Ace Glass. Thank you for joining. Um, I really want to start promptly at 11 o'clock because I really like this topic and I probably have a lot that I want to share with you. So I guess I'll start with me. Uh, I am a candidate sales manager with Ace Glass, and I've been with Ace Glass for about 3 years. I had a previous life in inorganic chemistry, chemical applications, and I have a PhD in chemistry focused on nanomaterials, specifically like copper alloys. Um, it's exciting, kind of, but anyway. So to get into photochemistry, it's a interesting field of science, primarily because it's been uh, basically it's been very further developed in recent years, but it was discovered years and years and years ago. As you can see, we noticed photochemical reactions as early as 300 BCE, and we were able to understand the principles of ultraviolet light in the early 1800s. But over the past 50 to 75 years, I think the advancements that we've observed are a lot more um, focused, primarily due to microprocessing and actually just due to microprocessing, to be completely honest with you, because now we have sensors that can provide feedback and so on and so forth. Now, the breakdown into photochemical applications with respect to glassware or with respect to testing in media, it falls into two caveats. And the reason I started this way is because it basically helps us understand how someone like you might use a photochemical reactor or have an understanding of photochemical applications. So quartz is used because it does not uh, inhibit the radiation associated with ultraviolet light. However, borosilicate glassware does. So basically, when you're designing something, you want to look at where how the energy is going to be transmitted through your media. Now, the energy sources are basically focused on a few varieties. We focused on mercury vapor lamps. So we have some arc lengths ranging from 69.85 millimeters to 317.5, and then you can go from 100 watts to 1200 watts. And of course, the power supplies for these systems are available as well. So, photochemistry has a few applications in a variety of industries. You have photo inhibition in biological systems. You have photosynthesis, which we're very familiar with because we all learned about it, when we were in grade three. Um, but what's really exciting is our applications like photochemical quenching or competitive photochemical pathways. And I just want to touch on photochemical quenching just a little bit because I have a little bit of personal knowledge on that. And it's really interesting as to how um, photons of light can either inhibit or um, promote a chemical reaction. And in this specific application, it's all focused on inhibition. Um, and the engineering around it or the design around it is unique because you need to control the energy with respect to wavelength and an overall power of sorts. But you also need to make sure that the refractive index allows for that energy and wavelength to pass through at a specific time. So it's almost like playing a little bit of an arcade game, which is kind of neat. Um, you also have photodegradation of catalysts or light-induced passivation. The What's illustrated is an ACE class inert atmosphere system, and there are some really interesting, um, I guess, features associated with photochemical applications when you're in an inert atmosphere. You just basically what happens is things travel faster generally. We all understand this based on light's transmission principles. But that's another application that is very specific to photochemistry. And of course, if you're trying to develop something on a significantly smaller scale, we have microscale photochemical applications. So, um, as you can see here, what's depicted, it's a 25 millimeter by 120 millimeter reactor. So, in instead of trying to understand what a reaction looks like in a larger system, you can always have a smaller system connected, so that you can kind of prove out your concept. So there another application that's really popular is the nuclear and wastewater treatment application uh, for photochemistry. And this is really interesting because not only can you degrade the waste, uh, or any type of material or biohazardous material that's contained within wastewater using ultraviolet light, primarily because of its ability to um, cleanse of sorts. You can also use it in combination with catalysts. So titanium dioxide is one of them where ultraviolet light on its own is very effective. However, in the presence of titanium dioxide, that ability is maximized basically. And really, what that translates to is the strength of the lamp, the wall thickness of your reaction vessel, and then of course the energy and flow through of the media that is running through the system. Now, as we all know, uh, the photochemical applications extend into pharmaceuticals, paints, and pigments. So what we're looking at on the right-hand side is a photooxidation apparatus reactor, which basically allows us to uh, run photochemical reactions continuously. I know that there are a variety of companies that employ this type of system primarily because the amount of time that the um, reactant is exposed to is it needs to be controlled, and in order to ensure that you don't have further reactions occur after that initial like excitement stage or exposure to UV light, it needs to be a flow through system. Now, we have the luxury of applying these principles into medical devices. So, what we're looking at here is an individual photochemical cell. Um, I actually have worked with companies that use this type of technology where they're actually using it for sensing radiological um, isomers within their applications, which is really cool because you provide it with you basically what you're doing is you're providing the system with a UV source. The radioisotope is already present in the medical device, and now there is a sensor that is now identifying feedback based on the amount of energy that's released from that radioisotope. The applications of photochemistry aren't just limited to like biological systems or organic chemistry, but they're also applicable in inorganic applications. One area that again I'm familiar with, and not to toot my own horn, is aerospace testing, especially with adhesives. Um, there are adhesives out there that need to be tested based on UV cycling, whether it's dynamic or static, at high altitude. And the ACE glass turntable reactor allows for this type of testing. Not so much that because it can test a variety of samples at the same time, but we can also place it in a chamber where the conditions are similar to that of high altitude, so lower temperature um, and low atmosphere or low humidity for the most part, very dry. Um, we can also use our we can also use photochemistry for photolithography, which is really popular in the electronics industry. And one interesting aspect is that you can etch titanium onto borosilicate glass. So although we don't offer the etching capabilities, the glassware that needs to be used is definitely compatible with this process. So if there's anything that you need that's a unique surface or whatever that is, we can now create that for you, and then you can etch onto it whenever needed. And of course, when you're practicing photochemistry or photochemical applications, you want to make sure that you're as safe as possible. So, ensuring that you're using your UV protective eyewear, testing within safety cabinets, cabinets that basically shield out all of the UV, um, using chillers to make sure that any energy that is introduced into the system is removed from the system as quickly as possible, and of course, water flow shutoff controller so that in the event that the chiller isn't operating optimally, there is a shut off so that uh, there's no risk of uh, extensive amounts of energy entering the system. Now, at this time, I kind of ran through that, but I did want to take some time to talk about photochemical applications outside of like in more of the education space as well. Um, and one thing that we've noticed recently is that there is an interest in the waste treatment applications over everything else. The there are a lot of there are a lot of applications where people are looking at treating wastewater because of the impact on the on our overall water supply. So with that, the with that, we've kind of looked at different opportunities as well. No, I know I'm a little I finished a little early, as I said before. If you have any questions, please feel free to contact me. My telephone number is 437-241-2972, or you can always get me via email. Um, I guess at this point, if it's all right with everybody else, I'd like to open this up for questions. So I have a question here. What is the largest reactor that you make? We have we have, I think, three sizes of photochemical reactor, 250, 500, and a liter. And then, of course, we have the micro scale. Don't be shy. Oh, here we go. Can a photochemical reactor be connected to a spectrometer? Oh, that's a tough one. Let me think. I mean, depending on the type of spectrometer that you're using and the photochemical reactor that we provide, I would want to say that we can create some custom glassware that would be introduced into your spectrometer if needed. Um, your inlet, we would need to know things like um, the inlet design um, and the diameter and the length or the distance from one system to another. Now, because the materials would be sensitive to light, it would make sense that the materials be constructed of either quartz or borosilicate glass and shielded. Um, so, it would be a fixed piece as opposed to like running a hose. But good question. Oh, I have another question here. Do you make amber glass? Once my reaction is complete, I would like to ensure that it is transferred to a stable medium. We do make amber glass. I think that would be a perfect pairing between the photochemical reactor and the spectrometer as well. Um, I think that kind of kills two birds with one stone, essentially. I have another question here. Does Ace Glass sell safety shields specific for photochemistry? Yes, we do. our photochemical cabinets specifically are focused on shielding uh, UV rays. Um, I have another question here. How can the reactor be chilled due to the heat generated by a lamp? Um, so the basically what we want to do is we always want to connect our thermal well, or well, not thermal well, but reactor well to a chilling source. Um, so that would be in the form of a thermal, I guess, like a water cooled or a chemistry cooled, refrigerant cooled system. So that allows for any energy that would be transferred to the system to circulate through at a given time based on whatever temperature you want to operate at, and then control that. And just to let you know, even though I did mention that we have reactors that are only a liter, we have manufactured systems that are significantly larger. We've done up to 10 liters. Um, and if needed, we could manufacture larger as well. There's another question here. Is our glassware or quartz compatible with laser diodes and LEDs? Yes, it is. Uh, the amount of energy that would need to transmit through borosilicate glass or quartz would be significantly less. So the only difference would be that you might want to use a thinner wall, just so that you aren't losing um, the energy due to um, transmission. But if that said, if you're just testing for a ultraviolet reaction without radiation, then I would say that yes, that we're completely compatible with them. Here's another really interesting question, only because I am addressing two markets. As I mentioned, I'm the Canadian sales manager up here in Canada, obviously, um, but I'm also speaking to a wider audience. Uh, One question is the photochemical equipment available with the CSA rating in Canada? Um, yes, this is available through our distributor network with Avantor. Um, the basically the system would be CSA certified once it crosses the border with Avantor. All right. So here's another question. Interesting. Are you familiar with FEP? Yes, I am. However, I don't. Um, I'll have to get back to you on that. So just for everybody else, if no one else knows, FEP is fluorinated ethylene propylene, and it's a material that could be used um, as a photochemical reactor. Um, I have used this material in the past, and I'll expand. I can expand on this later at a later point in time. But uh, we don't. I haven't seen us use it here at Ace Glass. I'm not saying that I don't think anything that we do here is impossible, but I would have to check with our tech team um, as to whether um, we can work with you for such an application. And we have a keener in the group here. What's the difference between low, medium, and high pressure lamps? Does ACE sell all types of lamps? So the difference between the three types is generally your spectrum um, range. So low pressure, you're kind of looking at, just below your infrared all the way up through to violet light. High pressure is going to be ultraviolet. Um, does Ace Glass sell all types of lamps? We can definitely source you what you need for your applications. I like these questions. Can you filter the subwavelengths within the UV spectrum? Uh, basic, in short, no. Um, However, the it's not impossible. So we'd have to calculate we would have to basically calculate the velocity, like the speed of light over the frequency. We'd have to identify what the frequency was and then use a spectrometer to understand what we're filtering out. So it would need some sort of sensor. Um, but again, or maybe I'm overanalyzing it primarily because I come from that world where we have to measure everything. But overall, there may be an easier way to do it, but I think that's the only way I'm familiar with. Um, is the 1 liter size most common? I honestly couldn't tell you what was the most common. I've seen us, we've definitely released all types, or we've fabricated all types. Um, I couldn't say, but I could definitely get back to you on that. And how much volume can be used with the 1 liter? Basically, we generally recommend about 40% capacity. So you're looking at about 400 milliliters. Um, have I worked with photochemical reactors? Uh, yes. Um, One time specifically, we were trying to activate a organic semicrystalline material so that we could deposit um, a copper alloy onto the surface. In order to do that, we needed to expose the semicrystalline surface to ultraviolet light, um, and then deposit the copper onto the surface. So we had to develop a closed system where um, we created an electrolytic cell that was kind of encapsulated or shrouded in a safety cabinet, um, and then we would create a pulse wave modulation or an on-off uh, application where we would excite the surface with ultraviolet light, turn it off, run the electrochemical cell for a specific period of time, and repeat until the process was complete and the surface was completely covered. So I would say that's kind of the extent of my exposure to photochemistry, which I think is pretty middle of the road. Another neat application that I saw years ago, and this was just because I was touring a paint facility, but there was a company that was fabricating paints, and they were using photochemical photochemical reactors for pacifying their paints. So again, it was using titanium dioxide, but basically this process that they used, it basically made their whiter paints whiter. Um, they were less susceptible to um, uh, like graying over time, and I think that a lot of that has to do with the fact that the it was there was a there was a reaction between the pigment itself, the polymer that carries it, and the opacifier, which is your titanium dioxide. So, I mean, I think that kind of brings my presentation to an end. I really want to thank everybody for joining. I really appreciate all of the questions. They were very stimulating, and I'm looking forward to the next one. That's for sure. And just to let you know, the next one will be Thursday, September 18th on programmable pumps with Shannon Meister.